taken this comparison study, whatever we had considered was the same airplane analysis, I mean, the aircraft delay analysis data set that we got. It was a simple use case itself. So I implemented the same in all four platforms. One is AWS, Azure, Hevo Data, and Gather, all four along with BDB. And so there is a comparison, and I've also noted down additional points which are beyond this particular implementation, meaning overall of the other additional features that is available in the other platforms, as well as maybe not for this particular use case. Maybe I considered several other use cases. Some of the cases say real-time data analytics or batch data, how we can process these in their platforms. So some of these study parameters are also considered in getting those additional points that is written. So this was the set of standard parameters which Sarat sent for comparison. The first parameter is percentage coding required and the drag and drop options. So in this, say with respect to this parameter, if I check on AWS, okay, let me just pull this back in for temporarily so that I can see that quickly. Okay. So now, when we compared the percentage of coding required for that simple use case, basically it was just some data preparation phase. You take the data from S3, do some basic data preparation like say drop null columns, check for duplicates, or replace some of the null columns with zero, or just very basic data preparation and data cleansing operations was carried out. For that, in AWS, again, AWS, when we compare, they have a lot of services. So whatever I chose was using Glue, AWS Glue. So AWS Glue, yeah, of course, that platform and that service in AWS could do this in entire batch, meaning it could take the entire data in one single batch. It could do all the processing that we want it, like say if we give basically these data cleansing operations, it could do on the whole on the entire data. It was not like any batch processing. It was not taking it in batches.
What was the size of the
Uh,
your taken data?
Okay, data had around 23 million records. Sorry, 2.3 million records. 2.3 million records, 23 lakhs. It was only around somewhere around 300 MB total size of data. Volume was around 2.3 million records. The data, entire data. So, okay. So, this when we compare, when I checked with BDB platform, we literally didn't want any coding. We could simply do it in our data alone, the basic data preparation without any coding, meaning I can use an S3 reader, get it into a data preparation module, data preparation script runner, and I could write it using our writers, whether it is to database, say MongoDB, or I can write it back to S3. There's a very simple process with BDB data platform. But for AWS, of course, one thing is while using AWS, we could still do it with minimal coding, meaning some of the steps they already had within their options in Glue itself. There are some operations, say for example, check for duplicates or maybe trim, basically the trim, trimming any white spaces. So for that, there's no direct option in Glue. And of course, there are many other parameters that is missing in Glue. Say for this particular use case, that was just like around 15 to 20% of coding was required. How we do it is like, okay, we select these operations. It will give us a code, meaning with the backend code, what it executes is on Spark. It gives us a code. We can modify on that code. So that is an extra step. That is the only extra step that I had to do. I didn't have to write a code there in AWS. But there are other AWS services in which we can still do this. There is there is another data pipeline module, and there are many such. We can use multiple. They have multiple services which can do this again. But there again, there are more coding required. But in Glue, there is minimal coding. So that's why I try to choose that and try to do with that. And then again, they don't have any drag and drop interfaces. Their services are connected. Yes, they are connected, but it is a lot more tedious to understand that process. Meaning they have a lot of services. We select one service. Okay, we tell we'll have to manually write different things. Okay, the output of this service will go to the next. Say we can configure an S3 reader. The moment an S3 reader gets a file, we can trigger our code. But for that, a lot of process. A person has to know that platform very well in order to connect them. But in our case, it is very easy. We just have them directly with the mouse, it's done. But that is not how easy it was in AWS. So AWS, you have to know the service, you should know which service is used for what, and you should also know how you can connect between services. So it was a lot more of training intensive, I would call, to understand this entire process in AWS. So it took a lot of time for me to understand, okay, how I can connect them, how I can utilize, and to understand, okay, Glue itself, it took some time. We have to refer to multiple videos, what is available, and all these things. And one thing is they have a good documentation, yes, but just by reading the documentation alone, we'll not be able to execute it easily. That is one thing, but they have a good set of documentation, yes. Maybe some video references or something like that will help in that case. And next, going to the development timeline, yeah. So this again, if somebody who knows AWS really well, they'll be able to do it. Years. That's what my estimate is, or maybe less than that if he's a really good expert. But when I tried with our trainees, so this I just gave it as an exercise to our trainees, sorry, our trainees itself, and they could do it in half a day with just the basic training. So meaning because when I give them our videos, whatever we already have, and I just tell them, okay, read this from some database, okay, using SFTP reader and implement it using our data prep. They could do it in half a day without much training itself. This was actually perhaps the second task which I gave. The first task I gave is, okay, get acquainted with data prep. Second task was this for them. And they could do it very quickly. So that is the easiness with which we could complete this in our platform compared to AWS. And so next up, we have connectivity to different sources. Yes. So AWS, yes, they have a lot of sources as their own services, and they will allow to connect to that. But anything external, say, if they want to connect to our MongoDB, we'll have to write about that, something like that. It is not that easy to connect within the service. Say, if Glue, I have to connect, I have to read the data from our MongoDB. It is not easy, but I can read it directly from S3, Amazon S3, Amazon's service. They'll be easily able to read it. But that is not how our platform is. Say, our platform, we could easily read from multiple sources. Like we have connectors. If there is something that is missing, we could still create. We allow others to or our platform to connect to others easily. But that's not how easily they allow. And so even their sources and their destinations are also like that. If they have to write the data somewhere, either if it is something else, you have to code it. For their own services, they don't have. We need not code. They directly have options. Which to say they have a relational database itself. They have no SQL database. They have this kind of data lake that is using S3 and stuff. So they allow to write easily on their separate services. And then yeah, others also it is possible. Only thing extra coding will be definitely required for that. Whereas
So no standard connectors for Oracle, SAP or anything like that?
No, directly it is not available. We'll have to check. Multiple are there.
Correct.
So then again, real time again. Compared to us, say they have some limited sources directly. Again, this Kinesis and Kafka support. Kinesis is their own service that can connect to multiple. So you just have to write a code there that will connect to multiple things. So we can send any live data to Kafka. Kinesis stream. Some Kinesis is something like Kafka, kind of their own service again, managed service by AWS. Which streams this real-time data. So they are capable of doing it very well, and that is a very robust system as well. But say we have these connectors, like say, for example, we can connect to WebSocket or Azure. They don't have a direct mechanism to connect to Azure, meaning they are more, what do you call, reserved kind of. They want people to use their own services, kind of a setup that they have. So yeah, that is one in terms of this connectivity to different sources. Then, yeah, again, the data transformation. So this is why it resulted in this 20% coding. So then their extent of data transformation options available compared to our data prep layer is much less compared to our data prep layer. So whatever I used was Glue for this. And of course, then the deployment type is there's this cloud. And in terms of AI ML capabilities, yes, they have an excellent AI ML capability. Again, they have that option where you can develop all these algorithms and stuff, and they can club it to even pipeline. They can put it to pipeline, and they have a lot of they have a very good AI ML capability. So this is what I've understood. But again, it needs someone who knows this really well to integrate how it can be, because even I still couldn't get how I can integrate what I write in their uh, SageMaker or something into a pipeline flow. Meaning they don't have a drag and drop interface. They have a completely they all the services are linked, but someone should know very well, okay, how to link them. Say there are some Lambda functions, they have something called Lambda that can get triggered on multiple things, and they have a lot of they have excellent options to connect also. Just that it needs a very skilled person there to do that. And yeah, coming to monitoring, yes, they have very good.
What about BDB in case of AI ML?
Yeah, so we have again it's just our whatever we had just written. Okay, so it is like it has we again have options on Python and R based models, which can be run in, and data science again model runner is a new component that is available DS Labs, so we can write the scripts there, and we can make sure it runs on what do we call the data science lab model runner component, and we'll be able to easily productionize the model that we do in data science workbench or the model runner, I mean the DS lab, into the pipeline. Okay, and coming to monitoring capability. So again, we have I mean the AWS, they have an excellent monitoring capability. They have something called CloudWatch, which is again a managed service, which is a service in itself, and it keeps track of every log. So it is like they have real time logging, and they have a history of everything. Every single run they have history. If there's a failure, how long it took, how many cores it used, how much memory it used, what time, how long it took to process the data. Everything is maintained for every run in their CloudWatch. So at any point, if somebody wants to go back and check their logs, their run history, or anything, it is easily possible in AWS. Of course, we do have a good monitoring option. We have it in we have mainly for real time. Now we have also implemented that keeping a history of failures and all. But still, say if we want to know the performance of the last run, or say a run which is conducted a couple of days back, then that is where we won't know, because currently we have, okay, the immediate previous run is very well being tracked. Uh, but say we want to check the run, say 2 days back or something like that. That is something which we may have to say comparatively compared to AWS. That is where our monitoring maybe a step back or something like that. And again, coming to errors right now, yeah. So errors we are keeping a track of the errors uh, as well. So some advanced option is available for us right now in terms of storing the errors, which was not there previously. I think in the 7.5 release that has been covered as well. And yeah, and another thing is they have their own notification system. Say if we have to configure any alerts for any failovers, they have their own SNS system that can be configured. Of course, we do have now. We have, but I think we rely on another service, right? Like for example, I think we rely on SNS again to alert somebody. And in mail wise, yeah, we have our own component, but maybe for say an SMS notification or something, we still rely on an external service, SNS itself. But considering that platform as AWS, they have it completely covered for them. Yeah. So, and these are some of the additional points which I just thought of putting it across. One is they have that serverless infrastructure, maybe meaning like say if we have a scenario where we would like to directly take an aggregate. Say I have 23 million, sorry, 2.3 million records that we currently have. Now we want to aggregate it and directly get the aggregated data and just store only the aggregated data. Say some use case like that. That is where this kind of an architecture or this kind of a serverless system that they have helps them. Meaning, if we have to do that, we will have to first store the raw data into a database and then try to get the aggregated data out of it. Run the aggregations on a database level. We will not be able to run it directly on the incoming data because we follow the micro batch architecture. This is where if they want to check for duplicates, if they want to check for aggregates, they can do it even before the data enters the database. So the extent of data that they write into the final destination will be much less if the target is only to find the aggregates in the entire batch of data. That is one big, say I would say an advantage when I see AWS compared to us. Yeah, then again, they have this, any code that we give, they have their clusters. We can configure clusters which can be scaled very well. Of course, payment aspects are also there, but it can scale to a very good extent. We can set the limit, or it gives a lot of flexibility there. So if you want to run any parallel processing, that is possible using Amazon's EMR or EC2. Yes, EC2 is just a small instance only, but EMR can do that. Elastic MapReduce service of AWS. So that is one where you can deploy Spark clusters and do that. I think maybe we don't have that kind of an option, but we have, of course, we have this Spark-based components which can run with multiple executors, but they are again with respect to whatever batch, single batch, sorry, micro batch architecture, whereas it's not on micro batches. They can take the entire batch of data together and do it. So that is one an additional point what was checked. And then again, in terms of investments, say we may have to, I think for our platform, we may need some initial investments in terms of setting up the initial, uh, what do you call, resources, say systems or how many cores, like yeah, license procuring stage. Whereas in AWS right now, I did with a free account itself, whatever we had, and only as you use, you're being charged. See, I think for this entire use case implementation, I was charged, I think, totally around $2. Actually, out of that, it's not actually $2, maybe $1. I had to, check what is possible. Say, Glue itself threw me a lot of errors in between while writing the code and all. But if you see, maybe somebody who knew that if they implement, maybe I think they would have done it at $1 because that entire run is very short. The Glue, the Spark cluster which run this code was very short. So it was a short duration. It would have not cost more than $1 maybe. Because I had to learn this and then do it, maybe it cost something extra. I think that is one thing. And then, yeah, this is something which I covered. Let's just go. Yeah, again, this data services and logging. See now, whatever I was just mentioning, I think this has been addressed in our 7.5 in our platform. They previously had logs getting stored within the S3 bucket that we created. We can specify, okay, store the logs in this particular location. It will store the logs there. So we can always go back and check the logs any point of time. Say whatever logs of the runs that we carry out, how many cores was triggered and how long it took, all such kind of data. Anyways, initially when I was just drafting this, I think 7.5 was not released. At that time, we didn't have anywhere where this was stored. Say mainly, I think, say for example, the Python components log itself, we have it for the immediate run. But the history, we cannot directly access it immediately. So if we had something like Datadog implemented, then yes, they can. There is a provision to see the logs of any previous runs maybe, but not directly in our platform. So that is one thing. And yeah, and another thing was the speed at which it processed. Of course, speed again, even we will be able to do it. But only thing is, say, I meant of the speed comparison as, say, if we want to do an aggregation, say finally this data was processed and we wanted to find out some of the metrics like which carrier performed better. So there was a lot of aggregation there. Basically, only for the aggregation, I have to store this data in Mongo and then do the aggregation when I was using our platform. But for them, if I just directly give this, they'll be able to easily do it. Meaning I just need to specify what is the SQL query. Meaning I do this data preparation. I take this as a temporary table within their memory itself after the data preparation. And I just write what is the SQL query I want. Directly, entire thing will be done in one single instance in AWS. So I don't have to write it anywhere and then run the aggregation query on the database. So that extent of time is not required when I had to use AWS. In terms of processing the data alone, maybe we will not be able to easily compare the speeds because they will do it in a serverless architecture. We can do it in parallel processing. So in terms of processing the data alone, even we will be able to match their speed. But in terms of doing the aggregation directly and then storing only the aggregated result, that is where maybe we will take a step backwards, or like we will have to first process along, then run the aggregation, put another script to save something like that. So this is one additional point. Yeah, again, this duplicate check also is included in the same as part of aggregation checks. Yeah, okay, this is again notification I think I covered. And some of the advantages is, this is some of the cons of AWS where our platform scores better. One is the easiness with which a new person can develop things in our platform. This is much better compared to AWS because a new person who was getting trained in pipeline itself was able to do this in very less time. Not even half a day. Maybe I think they were given some other additional tasks also, but maybe even less than half a day they would have done this using our platform compared to AWS. So this is one advantage that we have. Without much training, with minimal training effort, we can do this to compare to AWS. And then yeah, so here again, they need to know coding to some extent if they want to pick up these auto triggers, trigger this process after this, say read the process and then trigger the data preparation. They need some kind of coding or a deeper understanding of that platform. For us, we didn't have that. Just drag and drop, connect them together. We will be able to trigger the workflows. And again, sources are limited. Compared to ours, the data sources to which they can connect to are limited. As I mentioned, it is limited to their own services, mostly as standard options. And yeah, even custom scripts. Now, if I have to write a custom script in AWS and try to get it implemented, it is still difficult compared to us. For us, it is a very simple single component that we have, into which we write the code. Okay, we have the data, treat the increment data as just one variable, use that variable for the analysis. It is that easy for us, even if it is a custom script. But if I have to use a custom script there in AWS, it is still tedious. We have to specify a lot of variables from which it comes. We have to specify the trigger, then connecting all their other services. They have a set of specific codes which will run only in their platform to connect to other services. We don't have that kind of complexity. We just have a drag and drop, very easy to use interface compared to that. Even the data that gets returned from our custom code, if I have to connect it to somewhere else, or if I have the input data to connect to our custom code, both of them are very easy in our platform. And then yeah, so visualizing this flow in the pipeline. So we have very good UI to visualize the flow. Okay, the output of this component goes to input. If there are multiple components connected to this single input, again, we can see it very quickly. Right on us in a single screen, we can see everything. But in theirs, it is not that easy. So if I keep a trigger for any file entering S3, that would have been mentioned somewhere. Triggering this would be mentioned in some other service. So we don't have a complete, a very clear view of their connected services when we design a complex file. Maybe an architecture diagram, yes, but they don't have a UI which shows that directly. They have a pipeline, yes, they have data pipeline. In the data pipeline, if you have multiple things, that is C. But if there is any trigger that triggers a lambda function, I mean, in S3 triggering a lambda and then lambda triggering some other service, that is not easily visualizable compared to us, compared to BDB platform. That's one thing. Yeah, again, transformations also, we have entire thing listed, right? Yeah, here also they have a pretty good UI for it. It's completely easy again. Yeah. And then, yeah, say one thing, any unnoticed service running. See this, okay. Any unnoticed service running in idle in AWS will cost us a lot. Say one mistake which I did was, say, for example, I was, what is it? Yeah, I had one instance, which is an EC2 instance on which I ran a code that was in a different region. Say it was in, I think, some US region. And my bucket, the S3 bucket which I created was in India, the regions, what I specified. Now, just to read the data from S3, because these two are in different regions, it had a cost. It had an additional data transfer cost. Of course, they haven't mentioned, they have mentioned it, correct? Yes. So in order to minimize that, what I thought, okay, I'll shift the EC2 instance, the exact copy of instance. I'll try to get it to India region and try to run it so that I can avoid this cost. So there is a method in AWS that is like they create an AMI, that is an Amazon machine image. So we can create an image of that instance, save it somewhere, get that imported, just like our migration kind of thing, and then run it from India. So I can change the region to India. So what I did is, okay, I saved an image, I got it to India, yes. I got it running, stop the process, and everything is done. But they had a charge for storing that snapshot alone for some time. Oh, it's not a very big charge, it's a very marginal charge, but still, there is a cost which even I didn't know. Only when I checked the billing, there was like around $0.25 or something that was charged. And I got to know only after it got billed. I mean, after that process, towards the end of the month, they say, okay, this is the charge. They tell it as a snapshot charge. I didn't understand what it was. When I checked it, I got to know, okay. So there are that kind of things. We didn't use that literally. I did it only for one day. And I finished the process. I stopped it. Any such things running will cost us. So they don't have a single direct phase where I can check, okay, or I'm not sure if we really have that to see what all services are running. I mean, at a single place, maybe I can go to EC2 instance and check, okay, I can see this running. If I go to EMR and check, okay, there may be a cluster running. But do they show it to a user, okay, this many services are running? That is not something that is clear. Or at least I didn't get any direct dashboard to see this. Only when I checked that to today's usage is only known in the next day's billing. Next day, if I go and check, okay, it'll show you've been charged this much. That is when we realize, okay, there's something running. So that is something which I noticed. So I don't think we have anything like that. I mean, we are a lot more transparent in that case. We can easily see, oh, okay, any pipeline running, it'll just show in green or red. It's just a tap of a button. We can see which pipeline is running, which is not running. And yeah, again, logging, as I mentioned, they have a very good logging system, but just to store the logs, again, they charge. Any put or get operation or anything that you do on S3 is charged. They store the logs well. CloudWatch, even just to monitor that there's a CloudWatch service, that is also charged. Meaning after free tier, it is definitely charged. It may be less, but it is chargeable. We don't have any such kind of charges. Just to monitor, even though we have logs and we store the failover events and stuff, we don't have any such kind of charges, I believe. So that is where they, again, even a single put, I create a folder that is also built according to their this thing. It's the number of operation on S3 that they look at. So the similar study was conducted for Azure, where I implemented this. So comparing with AWS, yes, Azure was a little more easier, I would say. They had a couple of connected, of course, even they do have a lot of services, but there was an option where we could see at least better visualize their workflows when a new person tries to do it. So that is with respect to Azure. So we compare it to, again, BDB platform. With respect to the percentage of coding, it was 10%, comparatively much lesser than AWS. And they have something called this expression editor. Of course, even we do have. But their expression editor, it had a lot more of functions for doing the transformation. If somebody who knew expression editor really well, they could do almost all the transformation in that. In BDB, in data prep, again, we do have the expression editor, but we have the number of functions within that is comparatively lesser than what is actually available. In our data prep, I think maybe that is something which we can do improvise. But again, in spite of that, we that still needed 10% coding. That is because some of the some of the operations could not be directly achieved even with that. That wanted some coding, but whereas our overall data preparation module could do the entire thing. Even when we don't have that expression editor, which is not as good as Azure, we still could do it because we had other set of operations that is possible, which excluding this data, this expression editor. So then coming to timeline again, comparatively lesser for Azure compared to AWS. Not compared to BDB. BDB is still a lot more better in terms of a new person. We could still do it in less than say 1 hour or less than half a day. In fact, for sure, for a new person. Whereas somebody who knew Azure again might take 1 or 2 hours. If, so who really knows that, maybe half a day to 1 day or say 2 days, yes, for somebody who is new to explore the services, to understand which service to be used, where say the same workflow can be implemented in 2 ways. One is the Azure Data Factory, and there's something called Synapse also. Even there we can do it. It is part of Data Factory, yes, but in Data Factory there are two. One is Data Pipeline, and then the Synapse, Azure Synapse. So both the ways they could do it, we can implement this. I did it in Synapse, Azure Synapse within Data Factory. So yeah, somebody should know, okay, this thing to choose. That's basically next one. And then again, connectivity to different data sources. Yes, they have a good variety of sources, and it's not just limited to Azure. They have some more flexibility. They have a good sources where they can connect for batch. Yeah, and here it's not like there is better than us. We have little more flexibility. We can connect to Azure, AWS. Their services, they can, a standard database is MySQL, MongoDB, yes, they do support. But when it comes to, say, Azure connecting from AWS, again, there is a limitation. They don't directly support it, kind of a thing. But we don't have that. We connect to Azure, we connect to AWS without any such, competitive nature. And then connectivity to real-time sources. So their real-time sources are only these: Event Hub, IoT Hub, again Kafka and Blob Storage for streaming services. This is the only set of real-time sources that they have. Anything in excess of this, again, they might need coding and things. Whereas our real-time sources, we have a lot more. We have OPC, UA, we have a lot of options in terms of compared to Azure. We have much better options for real-time sources as standard connections. I mean, as standard connections, and then again, data transformation available. Yes, standard data preparation, data transformation options are less. Only the biggest advantage they have is that they have a full-fledged expression editor where you can test everything. That is possible. They have a testing editor. You can just write your code and just check, okay, is it running fine? And they also get a quick preview of whatever things it is using. And yes, again, it needs a skilled user, somebody who knows how to use expression editor properly. Say you have a pretty good transformation where you just have to find the null values and drop them, not consider them. It is not as easy as to use Azure compared to BDB. We could simply click on the column name, we could do it. We select the operation, we could do it. But in expression editor, it's like three operations clubbed together in one single line. So somebody who knows that, okay, how to club them together, so that kind of a skill will be required compared to BDB, where any new person can do it easily. And that is what actually reflects as this 10% coding as well as this extra development timeline in Azure. That is what actually reflected. It's not actually the user platform that here it reflected with extra time or extra hours. It's the skill requirement actually basically tends to reflect there. And again, yeah, theirs is on the cloud. And again, for AI ML capability, again, Azure ML is a service that they have, which can be easily utilized. There is a lot of options available in that to write and develop ML models and things. Only thing again, integration with pipeline is something which only a skilled person can do that. I mean, because it is a completely different service, how you link them. Say I have Synapse and I have this model that is there in Azure. How do I link it? It is possible, yes, but somebody who knows Azure in depth can only do. Whereas we have a standard component. If you know how to write a model in DS Lab, uh, just the basic code. Again, it's just a coding interface, right? So the same code that you write in Jupyter can be written there as well in DS Lab with very minimal changes. And we can easily export that, which can be directly implemented in pipeline. It is not that easy in Azure. Certainly, it is not that easy in Azure. That is so here I found our we have both. We have DS Lab or we even have model runners. So somebody who doesn't know how to code, say machine learning or say a simple linear regression or maybe a decision tree or something, some standard model. If somebody doesn't know to code, we can still use our data science workbench and we'll be able to easily implement it. If they know to code again, if they have the code, directly put it in DS Lab. So we support both of these models and it can be easily integrated. So that is the advantage that we see here. Again, monitoring again for them, yeah, they do have a good monitoring capability because they have a lot of services and that can be tracked. And and their monitoring facility is also available for every pipeline run, as I mentioned, very similar to AWS. They store the history of logs, and again, their logs are again going to be stored in blob storage, the storage which we give. Any operations into put operation, get operation again on the blob is charged after a certain limit, right? So if you have multiple runs or you have a lot of runs, again, there is a percentage of cost that comes in from that side. Yeah. And some of the points which I saw as advantages in AWS. One is again with respect to that serverless infrastructure, they could handle the entire batch of data together, whereas we process it in micro batches, the same what we discussed for Azure, sorry, AWS. Even Azure has it. They have single instances which can be scaled up as well, and they have the parallel, I mean, the clusters that can be launched for big batch operations. And yeah, so again, any custom code if you want to run on Spark clusters, that is also very well supported. Very similar to AWS in terms of that. You don't have to really worry about giving a fixed set of resources. They have the resources, but only thing once they scale up, will be charged accordingly as well. They charge for every code, every minute, every single operation is charged. They, of course, one that is where we have, say, we fix, say, suppose, and we were trying to get some data while we were processing, we have come across this use case wherein there is a data issue in one of their unstructured data that we get. And that alone was causing the memory and CPU to spike, to go for a sudden spike, just because a join didn't go well because there was an issue in the data. Say we were analyzing some data for some for a client wherein we were processing some trip data. So while we were processing trip data, was a scenario wherein there is a recorded by date. So there is every instance of the trip getting recorded. So what we were doing was we were doing some kind some intensive data intense analysis in that. So we were checking for how many seconds, second by second data, just to plot it and see the variations in some of the important parameters. So while generating the number of seconds for that trip, basically a trip, say it was a very finite trip. Oh, the overall trip was just only around 30 minutes, but it's first recorded and last recorded is what we basically check for calculating the number of seconds. What happened is there was a data issue in one of the data that we received. The end date came as 2024 instead of 2022. Like it's like 3 years of data, meaning you have a continuous trip that ran for 3 years. We couldn't code that because we are not anticipating anything on a very good data that we have. But we got such a scenario wherein every second by second, it just the data frame that got generated, the number of seconds that got generated was in millions together. We had a limit. So we said, okay, 4 GB as a limit. So anything that tries to overshoot that, it is cut off. But if that is the same thing that would have run on Azure or AWS, I don't know how much it would have charged, because it would have seriously went unnoticed. It is a join on top of such a huge data frame, because they have the scalability, yes. So I don't know what would have been the cost for that, or how much it would have cost just to process a data which is not supposed to be processed. So I think there I think we scored better in that case, because we set a limit. Okay, the maximum memory that can go up is say 5 GB. If we say 5 GB, our pod will stop at 5 GB. It will just stop processing at 5 GB. That's not the case for them. So there is a disadvantage as well if we, give that. Of course, advantages are much better. So this is just one example which just came to my mind. And okay, again, going ahead, one is the licenses. Initially, we don't have, sorry, okay, I think it's, yeah. Say Azure also does not have any start initial payment. We just, it's pay as you use, whereas we'll have some license costs associated for us. And yeah. And then again, they have multiple platforms, multi-platform services that they have. Automatic triggers are possible for them. Yeah, automatic triggers are available for them. And uh, again, linking multiple services is very easy there. And again, next point is they have their own set of services, databases, and logging facilities. So they have, say, for example, Azure Blob Storage is their own service in terms of data lake. And if they want a data warehousing solution, they have their own solution. So maybe BDB doesn't have its own database as such, as a managed service or something. But we rely on MongoDB, we rely on, so we support everything. Basically, we even take data from Blob, we even take data from S3. But because they have their own service, it is easy for them to store logs and do these activities. And yeah. Next up, again, with respect to processing speed, it's very similar to what I just mentioned previously with AWS as well. If we have an operation, the same example, the application operation or the operation to drop duplicates, we'll only be able to do it at database level because of the micro batch architecture. Next, yeah, monitoring and these things. Okay, so. Yeah, again, notification also, they have a set of notifications that can be easily set. We do have, but then maybe when we have to go for SMS service or something, we rely on another external source for it, external service for it rather. Just a second, I think I just made a mistake here. Okay, fine. Okay, so again, let us check what are the cons of Azure compared to BDB. So where we are better. So some of these are additional points. Yes. So one is how easily a new person can pick up. I would still say BDB is much easier because we just saw with our trainees itself. Even I took some time for me to check, okay, what service I can use in Azure because they have a list of services and how their interconnected service work. Because I still don't know how I can set up a real-time pipeline in Azure because the way our Synapse work and how I'm going to set the new use case is going to be different. Because they have different set of services for real time, but we have everything at a common place. We have, whether it is real time data, whether you want to process real time data or you want to process batch data, anything is available right in a single module and at a single place. You have everything sorted out in the order in the components panel. You just have to drag and drop it and do the processing as per what you want. That is something there. And yeah, again, extensive training and practice is required. Yeah, some basic transformation again, it needs somebody who knows coding, whereas we don't need to know that. Yeah, so these are some of the same set of what do we call advantages that we had. And visualization, again, we could see entire thing at one place, whereas they couldn't do. And even we can match their speed, or we can even surpass the speeds by using parallel instances. We have that flexibility using Kafka and multiple instances, whether it is Spark components or whether it is Docker based multiple instances. We are able to horizontally and vertically scale our pipelines to meet the speed, uh, just to process the data, including the model runners, implementing of AI models on the prepared data. Everything is possible on our platform. There's also, they do have, but it is a lot more complex in that sense. And yes, one more important thing that I noticed is, say, while you're applying transformations, while you do the transformations, the simple data preview is chargeable because they run on Spark. I apply, say, I've given one transformation just to see the null values, replace them with 0. Only to see whether it is working fine. If I have to test that, I have to trigger the cluster. It needs the entire batch of data. It checks that entire batch of data on whatever transformation I've applied. Only then I can see a preview. Where is the disadvantage is, say, for us, if you have to do, if you have the pipeline test framework, just one record is more than sufficient. We don't have to trigger the entire cluster. We don't have to read the entire data for this. But for them, that preview, just to generate the preview, I had to run the cluster, and that is chargeable. Running the cluster is chargeable again. So for us, it is just a pipeline test framework that would have done. A single input, we can see, okay, is the transformation working? Is that the desired output? So that is one thing which I noticed. Hey, that's the same even for AWS as well. They charge just for a test run itself, to see the preview. They charge, or they have to trigger the cluster. We have to wait for the cluster to come up and then do it. As I mentioned again, the same, any unnoticed service running in idle, because there is something called just this preview and test the pipeline run also. Even to test that pipeline run, there is a cluster that is triggered. And we have a time to trigger it off. There is an automatic cutoff time. The minimum time that I saw is 1 hour. So if you go unnoticed, minimum you'll charge for 1 hour. And don't know how much it goes. They have a good set of lists where it goes on charging. So that is one thing, and it keeps running. Ideal service, you won't have a central dashboard where you can see, or you have to generate reports, minute by minute reports that gets populated in the blob. Somebody has to go to the blob storage, see that file, open that CSV file, and then see, okay, what is running. Such kind of complexity is there where we don't have that. We just see directly how many pipelines are running. Just by a click of a button, we get to know that in the UI itself, the central UI. And yes, one thing is, uh, say, if one thing what I noticed is while writing to NoSQL database, something like MongoDB, there isn't an upsert process that is possible for except for underscore ID, meaning underscore ID is the primary key that they have, the primary index key that is there in MongoDB. If I have an upsert process which has to compare multiple columns and do, our standard component is able to do that. We have the option to specify the composite keys, and we can tell, okay, if not the underscore ID, if you want to check an update process based on a composite key, we can easily do it without any coding, but they don't have that option. Or at least I didn't see any such option. If it is control as underscore ID, that is index key, then the upsert process happens properly. But if it is a composite key, if I have to mention a composite key, there is no standard option available directly just to give this, or you'll have to control it in the code side. You'll have to write a code for it. That is one option which I think. Anyways, AWS didn't have an option to directly connect to MongoDB itself. They had an option to connect to MongoDB, but this is something which I noticed.
AWS has DynamoDB.
Yeah, DynamoDB. Yes, they have. They have their own service.
That's the original MongoDB.
Okay. Yeah, so this is with respect to comparison on Azure. So next comparison is on Hevo data. Just okay. So this, unlike AWS or Azure, they have only pipeline and they don't have multiple managed services as such. They have one module which is the data pipeline module, one service. And yeah, so compared to BDB, again, there's a set of standard transformations available for this use case. We still had a very small amount of coding that was required, extra coding that was required for Hevo data compared to BDB, because we have a lot more of transformation options which could be easily done. And coming to development timeline, yes. So if scripting is not involved, it may take almost the same timeline as ours, because even they have a good UI wherein they can use standard options. They do have a set of standard transformation options available, which can be easily taken care of. But again, the number of transformation options, the variety of transformation options are a little limited. So if there is an extra coding, again, they will take some more time. I mean, if you have to use Hevo data, it will take some more time comparatively compared to BDB. Then connecting to different data sources, there is a lot of variety. They have a wide variety of batch data sources. They can connect to multiple sources like MongoDB or MySQL, MS SQL, PostgreSQL. There are a good variety of sources. Even the other sources, say Twitter and such kind of sources. Even we do have, yes. So we have almost the same balanced. We are balanced in this comparison metric, because they have the same set of batch sources and we do have. There are certain things which batch sources which we have and they don't have, and similarly what they have and we don't have. So it is a little more balanced in that aspects. But when I go to real-time sources, what data has, it is a lot more limited compared to us. We have a wide variety of real-time sources to which we can connect as standard components, and they don't have that. And here, one important thing is, say we have an option to give a custom code for transformations, or we can independently deploy that custom code. Say we can write a code even for MongoDB reader. Say we want a custom reader. Say for example, ClickHouse. We didn't really have a immediate component available, but we could write a code as the first component in our pipeline, and I could easily fetch the data from that source. They do have an option to give a custom code, but that is only as part of transformations. They do not have a component in which I can run a custom code. They have an option to give a custom code, but it is in the transformation. Say I have to select a source. If I have to develop a pipeline, I have to select the source, I have to select the destination, and I have that option to select the transformation. In the transformation options only, I can give a code. So it is limited, meaning it has to take data, it has to give data. So it has to fetch the data, it has to give the data. There is no standalone deployment that I will see where I can use that to connect to a data source as such. See, it needs a source and destination properly configured. If I have to start a pipeline in Hevo data, that is what I got to know. And then, yeah, again, among the transformation options available, not all commonly used transformations are available for them, but of course, they have given the option to use a custom script for what we don't have, for what they don't have. If they don't have that option, they have that custom Python script. It's not a component as such, but in the transformation, you can give it. So we can get the data, we can do the custom transformation, and we can return it. And next, I'm not sure on their deployment.
The custom transformation, do they have an option to test it out? Whatever script
No,
they have written?
no, not directly. There is no direct test as such here. This is basically mainly for fetching the data from a source, putting into a destination. That it's like a standard template. You want to develop a pipeline, you want to give a source, you want to give a destination of this. Yeah, it's basically simple data transfer, data migration. It's not something where a full-fledged pipeline can be built with multiple, operations or large-scale pipeline. Is not what we would choose Hevo data for. That's that kind of a scenario, and they don't have an AI or ML capability. There's nothing that can be implemented like that. We cannot implement any AI or ML models as a package. Maybe you'll have to code it in your transformation. I'm not sure if that how complex would that be in their platform, because it's basically not built for it. So they don't have any out of the box standard AI/ML integration possible in Hevo data. And coming to monitoring, yes, performance metrics is available in terms of number of records ingested, transformed, mapped. Okay, they have something called auto mapping. I'll cover that. Some features that they have. And there's no component-wise performance metrics available, meaning resource utilization. No CPU or memory utilization metrics are available in their monitors to see how much CPU is utilized, how much memory is utilized. And they're basically their way of charging is if you have one record inserted in your destination, that is what you're charged for. You're not charged for the number of CPUs used or memory used. One record inserted into the destination, not in the source. The final destination, if you insert one record, that is what you're charged for in Hevo data. So, and yes, so another thing in their monitoring is they maintain a history of all the failed records, and it can be easily replayed quickly. Meaning, say, if I had mapped my destination in MySQL with, say, a data type, and if some records in my source didn't match that, then they are stored in a replay queue. I can change that and immediately give a replay. Automatically, it goes back into the destination from that replay queue. Meaning, we don't have to develop a new complete workflow for only processing this failed ones and do. They can just by clicking, okay, just do the correction, click on it. It will automatically check the failed ones and will directly send it to the destination. It will give a retry only on the failed. We need not run the entire workflow again as well. So whatever is already processed will remain as processed and will not read again. But whatever had failed, only that is processed and put back into the destination. And again, so that is one thing which I saw where it maintains a history of all the failed records. That's something that they have. And yeah, next, yeah, see, some of these are the data transformations that they had. Some of the date functions, this is the only set of data transformations they had in terms of data function, date function, sorry. It has changed date field, it's just format, and then event manipulation is like add field, change field, drop events. Yeah, some of them they already have, they have the standard options that we have. And then flatten, again, format number to string, pass number. Then security function, they have hash fields and mask fields. And the string function is modify string, text casing, split field. These are the only set of data transformations they have. Whereas if you look at our data preparation, the transformations available in our data preparation model, it's much more better. It covers a lot more of options, which basically minimizes the extent of code compared to Hevo data. That this is what basically reflected in their 5% coding requirement for this particular use case, whatever I just checked. Some additional points to be noted, some of the advantages which I saw. One is the auto mapping feature, which automatically maps the schema during data load. This is, we do have, but ours is like on the component. Say if we fetch the schema using the reader, yes, theirs it is a little more automated. If we don't have a, if we don't have a schema defined, then we go with standard. We have the option to map it in the writer again, but theirs it can be done. It is an auto map. Automatic mapping is available for their schema. So that is one feature which I saw for Hevo data. And then next one is a pipeline replay. It automatically, there's just by click of a button, we could replay all the failed events automatically. Whereas right now in BDB, I think with the 7.5 release, we are storing the data, whatever had failed. So we can again put we need one more additional pipeline or something like that to check this replay, just to retry on the failed events. Whereas there, they don't need any direct pipeline. We can just, with a click of a button, they could do the replay. And yeah, they have a replay queue. And for us, again, one more thing is how Hevo data treats the data. They treat one data as one batch, one event, one data, one record is one event. They don't take the batch. It is like take one record, process it, send. take one record, process it, send. This is how their platform works. They don't have a batch like us. We say 100 records you process at a time. No, that's not how Hevo data works.
You cannot aggregate.
Yeah, so direct aggregation is not possible. Theirs is basically just kind of a data migration. It takes only one record.
Why is that a pro?
It's not a pro. No, this is I'm just telling. It's not a pro. Why I told that is the replay queue. That is why they're able to achieve this replay queue. Okay, they store one record. If it fails, they store. But for us, because we are processing it in a batch, we have that issue. Meaning, if a record fails, our entire batch is kind of failing. If it is not handled properly. Say if we select 100 records, out of that, if a couple of records fail, then we tell the entire batch of 100 records is failed because we treat that in micro batches. Of course, we can. I mean, we are storing that as well, so we will be able to do that with the 7.5 release. We can handle it better. And yeah, next another pro for them is the connecting and serializing different workflows. Say they have an option where they can define multiple workflows for migration, and they can and we can specify, okay, after completion of the first workflow, then trigger the second workflow. That is one operation that they had. Say if we have to achieve that, again, we do have that flexibility when we have the components in batch. Say we have one workflow, we have the components in batch. After the end of the batch, so it has a lot of it's not that easy compared to implementing in your data where it is just migration in a sequential manner. We can do that as well, but if we have it across workflows, then we take some more time comparatively, I guess, with the batch modes. Each batch component has to come up, it has to go down, and so some amount of extra time that I calculated in BDB compared to Hevo data to achieve the same functionality, whereas it is directly available in Hevo data. Next, they had an option called this field delimiter. They have the option to set the field delimiter, say if it is a pipe, if it is a comma or anything. Whereas, of course, we don't have any such direct option in a reader, say, for example, a CSV file reader. But in our CSV reader, it is automatically recognized. But in a scenario where that has to be manually specified, then that is one option that maybe we can also think of in while implementing this readers or file type readers, just to read CSV files alone. And yeah, so customized alert for each user is possible. So this is one thing. So for us, we have a component which can send alert in a mail. And it'll be like, I think we have a component which can send a unified mail to multiple users, n number of users, but there they had each user who could be configured, okay, this user should get this kind of an alert for their pipeline, and the next set of users have a separate set of alert that can go. So that kind of a flexibility they had in terms of customizing the alert for each user in Hevo data. And yeah, another one is a log-based pipeline. This is basically capture data chain, CDC. They have any data, say we map when we develop a pipeline in Hevo, we have the option to select the source, we have the option to select the destination. If the source data changes, say I ran the pipeline today, maybe after half an hour or after 15 minutes, if there is a change in any data, it will only capture that change and it will reflect it in the destination. Say if there is a record that is deleted from the source after 5 minutes, if this is activated, it will immediately tell, okay, it will not permanently delete from the destination, but it will add a flag telling it is deleted from the source. So it is our option. We can choose to delete it from the destination if required. So they continuously keep track of that from the source, and their pipeline is like full-time active unless you stop it. So if I leave the pipeline, it keeps checking at every specified interval. It will check, is there any new data added that gets added? If there is any record deleted or modified, it directly reflects in our destination as well. So that is the change data capture that they have implemented on the log-based pipeline. And I'm not very sure on this initial investment. Of course, they don't have anything on resource servers or anything that I think is there. They just charge only on the record that is just inserted. So there is no investment on servers I'm very 100% sure on this, but yeah, this is the, I think they don't have any, but we have the initial servers and licenses that is required, license purchase. So that is one thing. Next, coming to where BDB platform would be better compared to Hevo is like this Hevo platform is basically only for extracting the data from a source, putting it into a destination. It is not capable of any, multiple other kind of transformations or these lookups or enrichments in terms of connecting to multiple sources. So such kind of a workflow is not directly possible in Hevo. Whereas we have that function, we can connect to a number of sources, we can look up with a number of sources, or we can also, send the data real time into, we can publish the data real time into multiple real time sources like, say, even Hub or WebSocket, we can integrate it easily with any dashboards. We have that flexibility in terms of that. And yeah, and number of destination options. This is very important. They have very less destination option. Even Mongo, writing to Mongo is not available in Hevo data. We cannot be written to Mongo, right? MongoDB as a destination. They have this relational databases, MySQL, PostgreSQL, MS SQL. All those are available, but this is something which I found they don't have a standard option to write to Mongo, because MongoDB is actually emerging to be something that can be well utilized. And yes, this is one con. This processes the data in batches of one record. That I think is a con. I mean, for us, they have utilized it in a better way for only for the replay queue, I felt. But in terms of data processing speeds, I think we would be much better if we use batches and semi aggregations or anything, or any such kind of processes. And yeah, again, data transformation options are comparatively limited when compared to BDB. And again, no option to integrate AI/ML, whereas we have a very good, excellent setup for that in terms of implementing AI/ML models and productionizing it on the data pipeline, where I didn't see that kind of a out-of-box option there. And again, yeah, this is the same. Not ability to publish to a message queue. They don't have any such option available. Anything that you have to do may be possible in the transformation option with custom code for everything, whereas we have standard connections available for achieving this very well and easily. So this is where our platform will be much faster compared to implementing other use cases in Hevo data. Maybe for this particular use case, whatever I checked, it was easy. They had the same timelines, but when it comes to a complex workflow, definitely, I think it'll be definitely BDB which will score better in that scenario. And again, no monitoring facility to know the system resource utilizations. Of course, they have monitoring only for number of records processed. At each stage, they show what is the number of records processed, successful, failure, everything, but not in terms of system resource utilization. Maybe because they're not charging on that. Sure. Yeah. So compute intense operation doesn't directly support this horizontal scaling. Maybe their backend, I'm not 100% sure on this, how they do, because they have to scale the single record. Yeah. So yeah, basically that's because of the single record processing, maybe. Yeah. So again, running complicated advanced pipelines is tough to achieve, whereas it is much easier in BDB compared to Hevo data. Yeah, same thing again. Requires more coding in case of any advanced pipeline, because they have the only option coding is in transformations, no standard readers, and it cannot be a standalone end component. Meaning I cannot keep a custom Python script as my destination there, and I cannot keep it as a source also there. It is only limited to a transformation stage inside the stage, and it is already connected. Meaning source is directly connected to transformation. If you don't give anything, it is understood nothing. So if you want anything to be written in the custom code, it will be only in transformation, which is already connected to input data and output destination. Yeah, so suitable only for maybe one-to-one data transfer between single source and single destination, whereas we know such limits. We have the option to specify multiple sources in the same workflow, multiple destinations in the same workflow. If you want more than one source, they need a different workflow for that in Hevo data. So that is with respect to comparison with Hevo data.